Yes, today we are going to discuss 11.8. 11.8 deals with a power series. A power series in x minus a or a power series centered at a is a real number, is a series of the form sigma n varies from 0 to infinity cn times x minus a the whole to the power of n. And that means c0 plus c1 times x minus a plus c2 times x minus a the whole square plus c3 times x minus a the whole cubed plus etc. So this is a type power series centered at x is equal to a. In particular, when a is equal to 0, it becomes sigma n varies from 0 to infinity cn x to the power of n, which is c0 plus c1x plus c2x squared plus c3x cubed plus etc. etc. There are three different cases. Case 1, the series is convergent only when x is equal to a. It's only one for one value of x. In this case, the interval of convergence is just a single number, the set A. Radius of convergence is 0 or is equal to 0. The second case is series is convergent for all values of x. In this case, interval of convergence is negative infinity to infinity, and radius of convergence is infinity. The third case is series is convergent when absolute value of x minus a is less than r. The interval of convergence is interval open interval a minus r comma a plus r, and the radius of convergence is r. The radius of convergence is one half of the length of the interval of convergence. So there are three cases. Interval of convergence is the set A. That means the series is convergent only for one value of x is equal to a only. Then second case, it is convergent for all values of x. And the third case, it is convergent only when x minus absolute value of x minus a less than r. And these are the three cases. And then the radius of convergence in this third case is r. So let us work out one problem. Find the interval and the radius of convergence sigma n varies from 0 to infinity. An is equal to x to the power of n. And we are going to apply the root test. I mean, not the root test, the ratio test. Yeah, it is written here. See, to find the interval of convergence and the radius of convergence, use the ratio test and always check the endpoints also. So find the interval of convergence and the radius of convergence, sigma n varies from 0 to infinity x to the power of n. And an is equal to x to the power of n. So an plus 1 is x to the power of n plus 1. So the series converges when limit n approaches infinity. An plus 1 over an is less than 1, and that is the ratio test. That is when limit n approaches infinity, absolute value of an plus 1 over an is less than 1 implies limit n approaches infinity, x to the power of n plus 1 over x to the n less than 1. That is limit n approaches infinity, absolute value of x less than 1. That there is no n here, so simply the limit is absolute value of x. So that is absolute value of x less than 1 means negative 1 less than x less than 1. So the interval of convergence is negative 1 to 1, and the radius of convergence is 1. But we did not check the endpoint. When x is equal to 1, see, x is negative 1 and x is 1. You have to check those two numbers. When x is equal to 1, an is equal to 1, when x is equal to -1, an is equal to -1 to the power of n, which is either +1 or -1. In both cases, the limit of an is not equal to 0. So the series is not convergent when x is equal to -1 and x is equal to +1. Therefore, the interval of convergence is open interval from -1 to 1, and the radius of convergence is 1. Question number 4 from the textbook. Sigma 1 to infinity means n varies from 1 to infinity, -1 to the power of n, x to the n, whole divided by cube root of n. So an is equal to -1 to the power of n, x to the power of n, divided by cube root of n. An plus 1 is equal to -1 to the power of n plus 1, x to the power of n plus 1, divided by cube root of n plus 1. Therefore, an plus 1 over an is -1 to the power of n plus 1, x to the power of n plus 1, divided by cube root of n plus 1, multiplied by the reciprocal of an, because you are dividing by a fraction. So multiplied by cube root of n, divided by -1 to the power of n, x to the power of n. Answer is going to be negative, because -1 to the power of n plus 1 divided by -1 to the power of n is -1 to the power of n plus 1 minus n, that is -1 to the power of 1. So it is -1. Then x to the power of n plus 1 over x to the n is x, and then under cube root n divided by n plus 1. So limit n approaches infinity, an plus 1 over an is equal to limit n approaches infinity, cube root of n over n plus 1 multiplied by absolute value of x, because x is here. So limit n approaches infinity, cube root of 1 over 1 plus 1 over n. You divide the common technique. You divide numerator and denominator inside the radical sign by n. So it becomes 1 divided by 1 plus 1 over n. So that is equal to absolute times absolute value of x. N approaches infinity means 1 over n is 0. So it is cube root of 1, which is 1. So it is absolute value of x. So that is the limit. So we go to the next page. Therefore, limit n approaches infinity, an plus 1 over an is less than 1 implies absolute value of x less than 1. That means -1 less than x less than 1. We have to check the endpoints. When x is equal to -1, an is equal to -1 to the power of n, -1 to the power of n, because x is -1, divided by cube root of n. Here two negatives makes -1 to the power of n times -1 to the power of n is -1 times -1 to the power of n, which is +1. That is equal to 1 over n to the 1/3. Therefore, sigma an is divergent by p test. P is equal to 1/3, which is less than 1. When n is equal to 1, an is equal to -1 to the power of n divided by cube root of n. Limit n approaches infinity, bn is limit n approaches infinity 1 over cube root of n, which is 0. So you recall what is the difference between an and bn? Bn is absolute value of a. That's it. So 1 over cube root of n plus 1, this is bn plus 1, is less than bn, since left hand side denominator is greater than the right hand side denominator. So bn plus 1 is less than bn, and that is sequence bn is a decreasing sequence. Therefore, by the alternating series theorem for convergence, sigma an converges. Therefore, for n is equal to 1, it converges. Therefore, this given series converges when x is an element of -1 to 1, excluding -1 and including +1. And that is the interval of convergence. And the radius of convergence is 1/2 of that length, which is 1. Number 8. Sigma 1 to infinity n to the power of n times x to the power of n. So there is exponent contains n, so root test is the best. n is equal to n to the power of n times x to the power of n. So n to the power of 1 over n is n times x, nx. Limit n approaches infinity, absolute value of n to the power of 1 over n is less than 1 implies limit n approaches infinity, absolute value of nx less than 1. This equation has no solution because n is infinity means absolute value of infinity times something which is infinity less than 1. It has no solution. Therefore, sigma n varies from 1 to infinity, x to the n to the n, x to the n is convergent only when x is equal to 0. When x is equal to 0, n is 0. So this is convergent only when x is equal to 0. Interval of convergence is the set 0 and the radius of convergence is 0. Number 12. Sigma n varies from 1 to infinity. Negative 1 to the power of n minus 1 x to the n divided by n times 5 to the n. So an is equal to negative 1 to the power of n minus 1 x to the n divided by n times 5 to the power of n. An plus 1 is equal to negative 1 to the power of n x to the power of n plus 1 divided by n plus 1 times 5 to the power of n plus 1 by replacing n by n plus 1. Therefore, an plus 1 divided by an is negative 1 to the power of n x to the power of n plus 1 divided by n plus 1 times 5 to the power of n plus 1 multiplied by the reciprocal of an, which is n times 5 to the n divided by negative 1 to the n minus 1 x to the n. So definitely it is negative, and the numerator has an x and an n because 5 to the n cancels. Denominator has 5 times n plus 1. The reason is 5 to the n plus 1 is 5 times 5 to the n. So 5 to the n cancels. And so it is negative x over 5, this extra 5 here, times n over n plus 1. As usual, you divide numerator and denominator by n. So it becomes negative x over 5 times 1 over 1 plus 1 over n. Therefore, limit n approaches infinity, n plus 1 over n less than 1 implies limit n approaches infinity, absolute value of x over 5 times 1 over 1 plus 1 over n. That is 1 over n is 0 because n is equal to infinity means 1 over infinity 0. So it is a 1. So that means the limit is equal to absolute value of x divided by 5. That must be less than 1. That is absolute value of x must be less than 5, meaning x lies between negative 5 and positive 5. Now you have to check whether the series is convergent when x is negative 5 and x is positive 5. X is equal to negative 5 means an is equal to negative 1 to the power of n minus 1 times negative 5, x is negative 5, to the power of n divided by n times 5 to the power of n, which is equal to 5 to the power of n. I mean, of course, it is negative. Negative sign is missing here. It is negative. Negative 1 over n. 5 to the n cancels. So that is negative 1 over n. That series is divergent because of the p-test. 1 over n means n to the 1. P is equal to 1. So by the p-test, that series is divergent. Now n is equal to 5. N is equal to 5 means n is equal to negative 1 to the power of n minus 1, 5 to the n divided by n to the n times 5 to the power of n. 5 to the power of n cancels, so it is negative 1 to the n minus 1 over n. It is convergent because of the alternating series test, because this is actually 1 minus 1 over 1 over 1 plus 1 over 2 minus 1 over 3, etc. n is equal to 1. It is negative 1 to the 0 over 1. So it is 1 minus 1 half plus 1/3 minus etc. That series is convergent. Interval of convergence is interval, open interval, left open interval, negative 5 to 5, including 5. Radius of convergence is 1/2 of this series. 1/2 of that interval, which is 5. Number 16. Sigma n varies from n varies from 1 to infinity, -1 to the power of n, x minus 1 whole to the power of n divided by 2n minus 1 times 2 to the power of n. So that is an n is -1 to the power of n, x minus 1 to the power of n divided by 2n minus 1 times 2 to the power of n. Now replace n by n plus 1. So an plus 1 is equal to -1 to the power of n plus 1, x minus 1 to the power of n plus 1 divided by 2n plus 1. See, when you replace n by n plus 1, it becomes 2 times n plus 1 minus 1. So 2 times n plus 1, that is 2n plus 2 minus 1 is 2n plus 1 times 2 to the power of n plus 1. Because this 2 times n plus 1 minus 1 is 2n plus 1. So an plus 1 over an is equal to -1 to the power of n plus 1, x minus 1 to the power of n plus 1 divided by 2n plus 1 times 2 to the power of n plus 1 multiplied by the reciprocal of an, that is 2n minus 1 times 2 to the power of n divided by -1 to the power of n, x minus 1 to the power of n. So -1 to the power of n plus 1 over -1 to the power of n is -1 to the power of 1. So that is negative. Then you have 2n minus 1 over 2n plus 1. 2 to the n and 2 to the n plus 1 cancels, leaving a 2 in the denominator. And x minus 1 to the n plus 1 over x minus 1 to the n is x minus 1 to the power of 1, which is x minus 1. So that is the ratio. Now you find the limit. Limit n approaches infinity, absolute value of n plus 1 over n is limit n approaches infinity. This is absolute value, so discard the negative sign. 2n minus 1 over 2n plus 1 times absolute value of x minus 1 divided by 2. And as usual, you divide numerator and denominator of that rational expression by n. It becomes limit n approaches infinity, 2 minus 1 over n over 2 plus 1 over n times absolute value of x minus 1 divided by 2. And that is 2 over 2, because this is 2 minus 0 over 2 plus 0, times absolute value of x minus 1 divided by 2, which is absolute value of x minus 1 divided by 2. Now you apply the ratio test. Limit n approaches infinity, an plus 1 over n is less than 1 implies absolute value of x minus 1 over 2 is less than 1. Multiply both sides by 2. You get absolute value of x minus 1 less than 2. That is -2 less than x minus 1 less than 2. That's the meaning of absolute value inequality. Add a 1 on both sides. You get -1 less than x less than 3. So you have to check the limits, the boundaries. X is equal to -1 means an is -1 to the power of n, -2 to the power of n divided by 2n minus 1 times 2 to the power of n, and this is positive 2 to the n divided by 1 over 2n minus 1 times 2 to the power of n. 2 to the power of n cancels. So 1 over 2n minus 1, which is greater than 1 over 2n, because the denominator is less. And so the power by P test, the right side is convergent, divergent. 1 over 2, sigma 1 over 2n is divergent, P is 1. So sigma an is greater than 1/2 times sigma 1 over n. Right hand side is divergent. Therefore, the left hand side is divergent. When x is equal to 3, an is equal to -1 to the power of n, 2 to the power of n divided by 2n minus 1, 2 to the power of n. That is -1 to the power of n divided by 2n minus 1. Therefore, sigma 1 to infinity an is equal to sigma -1 to the power of n divided by 2n minus 1 is convergent because of the alternating series test. Limit an is 0, limit bn is 0, and it is a decreasing sequence. An plus 1 is less than an, because 1 over 2n plus 1 is less than 1 over 2n minus 1. We have seen these kind of questions several times in the past. Therefore, the interval of convergence is negative 1 to 3, including 3 and excluding negative 1. Radius of convergence is 2. Next, question number 20. Sigma n varies from 1 to infinity, 2x minus 1 whole to the power of n divided by 5 to the power of n times square root of n. Therefore, an is equal to 2x minus 1 whole to the power of n divided by 5 to the n times square root of n. An plus 1, replace n by n plus 1, you get 2x minus 1 to the power of n plus 1 divided by 5 to the power of n plus 1 times square root of n plus 1. Therefore, an plus 1 over an is 2x minus 1 to the power of n plus 1 divided by 5 to the power of n plus 1 times square root of n plus 1 multiplied by the reciprocal of an, that is 5 to the n square root of n divided by 2x minus 1 the whole to the power of n. And to simplify, you get 2x minus 1 to the power of n plus 1 minus n, that is 2x minus 1 in the numerator, 5 in the denominator, because 5 to the power of n plus 1 is 5 times 5 to the power of n. 5 to the power of n cancels, and under radical sign you have n divided by n plus 1, and as usual you divide numerator and denominator by n. So absolute limit n approaches infinity, absolute value of n plus 1 over n, an is equal to limit n approaches infinity, absolute value of this expression, that is 2x minus 1 over 5 times square root of n over n plus 1. Under the radical sign, you divide numerator and denominator by n. You get limit n approaches infinity, absolute value of 2x minus 1 over 5 times square root of 1 over 1 plus 1 over n, which is, this part becomes a 1 because 1 over infinity is 0. So this is square root of 1 over 1, which is 1. So it is absolute value of 2x minus 1 over 5. Now apply, this must be less than 1. So that is the ratio test. Limit n approaches infinity, absolute value of an plus 1 over an is less than 1 implies absolute value of 2x minus 1 over 5 is less than 1. Multiply by a 5, you get 2x minus 1 less than absolute value of 2x minus 1 less than 5. It's a absolute value inequality. So you recall the solution of the inequality. Absolute value of 2x minus 1 is less than 5 means 2x minus 1 lies between negative 5 and positive 5. You add a 1 on both sides, you get negative 4 less than 2x less than 6. Now divide both sides by a 2, you get negative 2 less than x less than 6. And now you test the endpoints. When x is equal to negative 2, an is negative 5 to the power of n divided by 5 to the power. Where is an? An is 2x minus 1. So when n is equal to negative 2, it becomes 2 times negative 2 minus 1. 2 times negative 2 is negative. 2 times negative 2 is negative 4, minus 1 is negative 5. That is why you have a negative 5 to the power of n. So negative 5 to the power of n divided by 5 to the power of n times square root of n. That is negative 1 to the power of n times 5 to the power of n divided by 5 to the power of n times square root of n. This is negative 1 to the power of n divided by square root of n. And apply the alternate series test. Limit n approaches infinity, 1 over square root of n is 0, and bn plus 1, that is 1 over square root of n plus 1 is less than bn. Therefore, it is a decreasing sequence. That means This is convergent when x is equal to -2. And when x is equal to 6, an is equal to pi to the power of n, that is 6 times x is equal to 6. 2 times 6 is 12 minus 1. It's actually 11 to the power of n. I think there is a small correction there. When x is equal to 6, when x is equal to 6, it is 2 times 6, 12, minus 1, 11 to the power of n divided by, so this is 11 to the power of n divided by 5 to the power of n, and that it simplifies, and it is going to be a divergent sequence. You have to use the comparison test and the p-test. So that is, yeah, this part of the proof, there is a small mistake in the proof. Interval of convergence is -2 to 3. Oh, x is equal to this is question number 20. I will work out this question number 20 and give you the proof later. So just discard question number 20 because there is a small mistake towards the end. Number 24, that is the last question. Let us see what it is. Yeah, this is sigma n varies from 1 to infinity, n square x to the n divided by 2 times, 4 times, 6 times, etc. times 2n. That is an. An is n square x to the n divided by 2 times, 4 times, 6 times, etc. n. And you see 2 is a common factor everywhere in the denominator. So that is 2 to the power of n. 2 times, 2 times, 2 times. So there is a 2 to the power of n. Factoring out the 2 from all the even numbers here. So n square x to the n divided by 2 to the power of n times 1 times, 2 times, 3 times, etc. up to n, which is n factorial. So the an reduces to n square x to the n over 2 to the n times n factorial. Therefore, an plus 1 is n plus 1 the whole square x to the power of n plus 1 divided by 2 to the power of n plus 1 times n plus 1 factorial. Therefore, an plus 1 over an is n plus 1 the whole square. You have n plus 1 the whole square, x to the power of n plus 1 divided by 2 to the power of n plus 1 times n plus 1 factorial multiplied by the reciprocal of an, that is 2 to the n factorial over n square x to the n. And so, one of the n factorial divided by n plus 1 factorial is n plus 1. And 1 of the n plus 1 cancels. Then x to the n plus 1 over x to the n is x. Then 2 to the n divided by 2 to the n plus 1 is 1/2. So it reduces to n plus 1 times x over n square times 2. And divide n plus 1 over n times n. This n square is written as n times n. So this is 1 plus 1 over n times x over 2n. So the limit n approaches infinity. N plus 1 over n is limit n approaches infinity. 1 plus 1 over n times x over 2n, which is 0, is always less than 1. Therefore, sigma an converges for all values of x. The interval of convergence is -1 infinity to infinity, and the radius of convergence is infinity. I know this problem needs good algebraic skill, so you practice it. In case of difficulty, meet me during the online MATLAB hours. And number 20, I will workout number 20 by correcting the mistakes, and I will post it today or at least by tomorrow. If you don't see it by tomorrow, please let me know by through an email.